turns out that while add and get will be perfectly fast, remove will be slow. Now you might say, if you're just kind of casually watching and not thinking very hard, how can that be? We have last here, so we'll just aim our big giant deletion death ray at this thing, shoot it, 50 explodes, we don't have to ever think about it. But that's not what removing means, right? That's not how we delete. Deletion, in fact, will be about changing these 2 pointers in red. So specifically, if we want to delete this node, it means first we need to set this to null. And, well, I guess I'll just leave it null. And I also need to point last at this box here. So in effect, in order to delete the final item in the list, we need to somehow know where the second to last item is, because we need to be able to change this, and we need to point last at the second to last item. So in other words, in order to delete from the end of the list, even if we have a last pointer, we're still going to have to iterate to find the second to last item. So why can't we just cache the second to last item? Well, it turns out you can just inductively work your way along and say, well, in that case, we'd actually need to find the third to last thing in order to set the second to last pointer and so forth. So that approach of just adding a single cached value is not going to do it for us. Okay. So to get from here, this state, to the deletion state, we need more information than we could possibly store just in some little cache up at the top level. So what I'd like you to do now is consider, what could I do, right? This is a good start, I'll tell you that. But what can we do to the overall structure of the list so that remove last is also fast? So think about that a little. You have to do something else other than just adding a pointer up here. That's not going to get you anywhere. So think about what else you might do.